Welcome back to campus, Dr. Erica Smithwick. She's a jumbo. She graduated with the class of 1995 with a major in environmental studies and geological sciences. And she has had a really accomplished career ever since. So when I heard that she was doing a sabbatical in Harvard Forest this year, I reached out to her and convinced her to come visit us for a day. So thank you for doing that. And nowadays, she's at Penn State. She's a distinguished professor of geography, the director of the Earth and Environmental System Institute, and the associate director of the Institute of Energy and the Environment, among many other things. She wears many hats. She has worked extensively both in the US and internationally, and her research has been very well funded through multiple federal agencies, including NSF, NASA, DOE, the Park Service, to name a few. Her work her trademark is transdisciplinary partnerships to solve complex environmental challenges. More specifically, her work supports sustainable land management decision-making with particular focus on carbon sequestration strategies and forest resilience to wildfires, which is what she will be talking to us about today. So without further ado, please help me welcome Erica back to campus.
Thanks, everyone. Can you hear me okay? All right, great. Oh my gosh, it is so fun to be here. Students in the audience, do not blink because 30 years from now, you might be doing this as well. I can't believe it's been that long. Tufts will never quite leave you. I inadvertently painted my living room blue and brown last year. I didn't actually mean to do it. And then I was like, why is this so familiar? And then I was like, oh my God. So wonderful to be here. I'm going to today take you on first a little journey of kind of my life path as I was requested. I thought I took a quite academic path, but it's been the most interesting life course I could possibly have imagined. And I'm happy to share a little bit about those experiences. And then I'm going to introduce this concept of a firescape. And we have to kind of understand fire ecology a little bit before I start talking about fire more specifically to certain geographies. And then I'm going to talk about a good bulk of my career as research, which is focused on the Yellowstone ecosystem and the subalpine Rocky Mountain region in the West, and kind of what we learned from Western wildfires. And when I moved to Penn State, I did not think I would be studying wildfire in the East, because you don't study wildfire in the East, you study it out West, and I continue to do so. But for reasons I will explain, we are now very interested in wildfire risks for the East. And so I will talk about a new project that we just got funded on to create a network to try to set a research agenda for understanding Eastern wildfire risks. So I now sort of covet another mascot, the Nittany lion. I have been at Penn State for 18, 19 years, something like that. And I've really enjoyed my time there. It's been a great place for me to conduct a lot of my research. I have collaborations. I have 3 children. We love raising them there. It's been great. But it's also great to come back here this year. I'm on sabbatical. I'm working at the Harvard Forest Research Station out in Petersham, and I'm living back in my old hometown in Amherst, where I actually am from. And so my life feels very circular coming back. And so it's allowed me, and especially this seminar, so thank you so much for inviting me, this opportunity to kind of reflect on how I got here and how Tufts has launched me on this journey that I've had. So how Tufts have shaped me. I have a lot of points here. And I could spend the whole talk just on this, but I'll go kind of quickly through it. First, having this major of environmental studies and geological sciences at the time was so profound. In fact, I looked at my undergraduate choices, and I didn't find any place other than at Tufts where I could do exactly what I thought I wanted to do, which was to get this core deep training in a scientific field, but also to have this breadth, also to be able to ask questions that were broader. And so I was really pleased to have this opportunity to do that through this program at Tufts. And what it did is it allowed me to take classes in international affairs. I remember specifically a course on world hunger that I took. But I also was in the geology department at the time when it was just Jack, Ann, and Bert back in the day. And this was just such a wonderful community And I took rigorous classes, petrology and mineralogy, sedimentology, glaciology, and it allowed me to think as an Earth system scientist about how the Earth is formed and how it's reshaped, and everything from volcanoes to glaciers. I was just riveted with that deep core knowledge of thinking like a systems ecologist, or a systems thinker, I should say. And then I had this breadth of thinking about social sciences to environmental sciences. And I think that's why I'm a geographer now. Why I landed in a geography department was because of this training. Geographers can do all sorts of things. and so it was a good fit for me. I could have easily have landed in a geology department. I could have landed in an ecology department. But I ended up getting an offer to do a master's program at the University of Montana. And they said, well, you're a geologist. You must know soils. We want you to teach a soils class as a teaching assistant. And I was like, I know nothing about soils. Soils are what you put away so you can look at the rocks, right? And it happened to be in a forestry department. Similarly, I didn't know anything about trees because we were just looking at the rocks, and trees got in the way out here, right? But yet I came embedded into that program and learned so much, kind of worked my way up through the ecosystem. And in fact, my master's experience was with the Missoula Fire Lab. They had a research project in Zambia in Africa. And so I was able to go take part in field research there, where we were studying the atmospheric emissions of biomass burning in Africa. So all of a sudden I was studying atmospheric chemistry. But in some ways it was fine, because I was like trained as a geoscientist. I was like, well, it's the Earth. It all fits together, right? So anyway, that's a long-winded way of saying it really mattered that I had this program and this broad training in terms of how it shaped my research moving forward. I was on crew here. That was tremendously formative. I still have a lot of friends there that I'm still in touch with now. We've reunited, especially over COVID. We started to get back in touch. We're trading book club information now. But that experience was also transformative. I'll tell you one quick story, though. The head of the Charles, of course, is here. And our boat was going to go on to the head of the Charles, but I did not get placed in the lead boat. And I was kind of pissed, frankly, because I had worked really hard. I had, walked up hillside every day. I trained on the erg. I had done all of this really hard work over the winter. And I remember going into the coach at the time before practice one morning, and I went up there and I was like, this is my case. I have worked really, really hard for this. And I'm really disappointed that I wasn't in the first boat. Next time practice came up, I was in the first boat, and I was able to go on the head of the Charles. And it was that kind of like chutzpah, that kind of confidence building that I got not only from doing the training every day and the habits that you get by doing a sport like that, but also just like knowing how to advocate for yourself. So those things are really important. I also had the opportunity to study abroad while I was here. Missed a year at Tufts, unfortunately, but I got to go to New Zealand and I got to go to Australia in 2 separate programs. It was actually through Butler University, but I had all my credits. I had to take geology classes, so I had to go somewhere where I could understand what was happening. I had to take hydrogeology. So where in the world can I take hydrogeology and understand it? Because I was taking French and Russian at the time. And I was like, I'm not taking it in Russian. But anyway, so I went to Australia and New Zealand, had a wonderful experience. And I remember seeing my first recumbent fold in the deserts of Australia and thinking, oh my gosh, I understand enough of geology that I know what that is. And that was also really, really formative. And then here I had a lot of extracurricular activities. And again, one small anecdote, I remember folding pamphlets for the Rio conference, which was like the big environmental conference in 1992 that set the stage for thinking about what sustainability is and set the stage for future climate agendas. And now I'm actually going, or have been to, several of the COP conferences in Glasgow and Dubai at some of these international climate-related engagements. But being able to fold the pamphlets and not go there was kind of sad. But I was a work study student, so I did what I had to do. But now, it set me on the path of like, I want to engage in this kind of work more formally. Anyway, I could go on, but a lot of what I see now that I do in my work, I can root it back to Tufts. Okay, so what do? I'm going to have 2 slides. The first one are going to be kind of 2 overview slides of some of my research trajectories. First one, just in the US. I'm going to, again, I could give a talk on each one of these studies, but I'm not going to do that. I just want you as students in particular in the room to see the breadth of what I've been able to do in an academic career. Some people think being an academic is narrowing. For me, it's just like opened up the world, because you can study a lot of things as an academic. You have a lot of flexibility. So after my time at the University of Montana, I went on to a graduate program at Oregon State University, where I was able to study old growth forests. It turns out I fell in love with trees, and I was really interested in knowing more about how they grew, how much carbon they stored, when they got disturbed, what happened to them. And I had an amazing advisor who also studied old trees and dead wood, and really did a lot of core work in forest ecology. And then I did a postdoc at the University of Madison, but my mentor there was also engaged in research in Yellowstone. And so most of her career was there. And so I got involved in wildfire through that experience, where for 5 years I studied both fieldwork and modeling wildfire in the West. And then, went to Penn State, got involved in a number of projects through interdisciplinary collaborations, and ended up being funded to study forests in the Menominee, which is located in what is now present-day Wisconsin. Their reservation has this very tremendous sustainable forestry initiative, and we were interested in how it was shifting. And so we used the sexy part of this is that we used virtual reality to translate a modeled forest future, and then use that to engage people today about what they liked about that image, what that immersive experience let them think about how they wanted to manage the system today. Anyway, really, really fascinating project. I've also worked in Alaska. We have a project that just finished looking at coastal resilience and community resilience to climate changes in the Alaska context. And then somewhat more recently started to think about fire in the East, which I'll talk more about here today, but thinking about prescribed fire management in the Mid-Atlantic region. So my work has covered a lot of geographies, and I've also been thinking about how I'm training graduate students in this program. So we've been funded to develop transdisciplinary training programs for graduate students at Penn State about how do you do work that's very engaged in all of these projects. It is about forest management. You're working with managers, or you're working with local communities, and in many cases working with indigenous communities and Native American communities. And what does that mean? How do you do that work? I was trained as a geologist. How do I know how to do that work? And so I learned along the way, but we wanted to get ahead of that and think about how can we train graduate students to become prepared, become more confident in doing that kind of research. Okay. And then a whole other side of my work, which I'm not going to talk about today, is work in Africa, inspired largely from this work in my master's doing the biomass burning in Zambia. But I also was part of a large interdisciplinary project looking at human health and gold mining in Ghana. That's a whole nother talk. Over the years, we did a study abroad program in South Africa. I did engaged research there, thinking about indigenous forest stewardship, carbon sequestration in South Africa. Going to South Africa next month. And then we have several projects here, one in Kenya, where I'm looking at the intersection of land use legacies, climate change, and human livelihoods in Kenya. And then another project where we're looking at forest restoration strategies in Malawi. So it's a lot, right? My work has gone in many different directions. Sometimes that's because you go where the funding, you follow the funding. Also because I just wanted to work on things that were fun and interesting. And my role has become broader. I'm more of a systems thinker now. I think about landscape planning. I'm a landscape ecologist, technically. And so I think about space and pattern and reorganization of systems. And so I can fit that concept into all of these different projects. Happy to talk about any of those later, but I'm not going to talk about it now. So you could kind of say with my Africa work, I've traded this elephant for this one. Okay. So I also have a lot of administrative work that I do, also mostly fun, except for when it's not. But I direct the Penn State Climate Consortium, which is an effort across Penn State's colleges and institutes where we want to bring together climate science and have it have impact in this sort of interdisciplinary and transdisciplinary way. So we've done that by organizing faculty hires. So we've hired 10 different faculty across different colleges who touch climate in different ways. It could be through the arts, it could be through communication, it could be through policy or natural sciences, or in physical sciences, engineering. We also we host an annual symposium every year. We're really about focusing on partnerships and building events that bring people together. And we're investing in scalable research. So we have a whole program, we call it an accelerator program, where we fund teams. They have to have an outside partner, not just multiple disciplines from the university, but they have to bring in an outside partner as well. in order for us to fund them. And so we're trying to kind of entrain a transdisciplinary approach in our research community. Just to give you an example, last year our symposium, it's open, by the way, it's open to the public, so please come. Last year we had Namonte Nquimo, who is an Amazonian indigenous activist, come, and she talked about her fight against oil industry in the Amazon. Before that, we had Paul Nicklin. He's a National Geographic explorer, proponent of saving the ocean. And then we had Mustafa Santiago Ali before that, talking about environmental justice initiatives and how we can move that forward. So we're really trying to have this be a premier event for the Commonwealth of Pennsylvania and broadly to bring people together to talk about these issues, these things. So our accelerators, again, just to give you a sense of what we do, things like this one at the top, looking at high integrity forest carbon offset, another one at the bottom, looking at indigenous lands, looking at community health for elders who are particularly vulnerable to climate change. Anyway, a diversity of projects that we've been able to invest in, which is sort of fun. And then more recently, we were funded by the Commonwealth of Pennsylvania to lead an initiative that we're calling Prepare PA, which is how do we prepare the Commonwealth of Pennsylvania for an uncertain climate future? We're really thinking about flooding, we're thinking about electricity resilience, we're thinking about health issues, and how can the 8 agencies of the Commonwealth that want to coordinate around this, how can they come together? What should they be prioritizing? But also what partners should they bring into the conversation? So Penn State is now going to be the lead organizing entity for the Commonwealth and trying to do this. It's an ambitious project. We're just getting launched right now, but we have all sorts of tracks that we are thinking about in terms of how to do that. Okay, so that's a little bit about what I do on a day-to-day. It's a lot, but actually what I'm really passionate about and what I'm really excited to talk with you about is one of those threads that does weave in and out of a lot of these, which is ecosystem disturbances and particularly fire. So how many of you have heard of Prometheus? Okay, done your classics. Yes, he was a Titan god, and he basically stole fire from Zeus and gave it to humans. And this angered Zeus very much. And so Prometheus was punished, and he was tied to a rock, and an eagle, or some stories say it's a different kind of bird, but basically eagle or vulture pecked out his liver every day, and then his liver grew back and they pecked it out again because he did this thing by giving humans fire. So keep that in mind as we have this little discussion today. Of course, we're all used to fire. Fire is almost innate to human culture, right? We all hopefully have had an experience of sitting around a warm campfire, maybe having a s'mores. Humans have done this for millennia. And it turns out that recently evidence has extended the time period back to 400,000 years, where we now have evidence that humans have used fire purposely. There was some question anthropologically whether it was sort of they took advantage of accidental fires or whether they actually purposely used fire. Regardless, the evidence seems to be mounting that we can go back to our Neanderthal friends and ancestors to think about our connection with fire. And of course, it's incredibly useful for hunting, for scaring game out and corralling them. It's useful for promoting different kinds of species that you might want. Native American cultures here have burned regularly, we understand, for promoting nut-bearing trees, for example, that depend on fire. There's some evidence that this ability to cook our food, to cook our meat, actually helped increase brain size. And so it's very much tied to our ability to evolve as humans. So we're clearly connected to fire itself. It's one of the core elements in many mythologies. So there's an importance of fire. We kind of depend on it. And I would broaden that to say we actually depend on combustion more broadly, right? Fossil fuels is a combustion process. So we depend on this for our livelihoods in all sorts of ways. But with that has now come some very dramatic risks. And I'm sorry, the screen is a little dark. It might be hard to see, but can you see a kangaroo in there? Okay, so these are the tremendous bushfires during COVID. I actually keep this slide in here just as a reminder that this was I put that slide deck together when I thought that was the worst thing that was going to happen in 2020. And then something else happened in 2020, like a month later. And Australia's on fire again right now as we speak. But the tremendous bushfires in Australia. This is the fire in Lahaina in Hawaii. These are the many big fires in British Columbia and Canada. And, you know, burning through tundra ecosystems. You know, as a fire ecologist, someone who's been thinking about this and thinking about climate change now for decades, you know, thinking about systems that we know they do burn, like they can burn, but looking at the scale and the severity of these fires is actually quite alarming. And here's just an example of one of those fires in 2023 up in Quebec. And, you know, the size and scale of these is pretty dramatic. And again, there is, you know, 1.2 million hectares burned. I mean, you put a footprint of a fire like that over the East Coast, and we have a kind of a problem. And if not, I don't think we're talking in that way for what I'm going to talk about here for fire in the East. The fires in Canada have a long history. We know these systems burn, but we are in a time where we can look back. We have data records to sort of say, well, how often did they burn? How big were they? And we can now show that some of these fires far exceed what we have from the observed record. And so you can see the 2023 footprint of burned area relative to the past. And this doesn't go back too far. We can actually pull this back even farther, which isn't to say that there weren't some big fires, but it's very clear that the fires we're seeing now are different from what we have managed recently, at least. And so we're also in an era where they can cause feedbacks to the climate system. So for example, now we have these fires burning through peat and burning through tundra, releasing a large amount of stored carbon into the atmosphere, having things like zombie fires. I don't know if anyone's heard that term now. You have? I mean, this is like something we didn't really talk about, but now we know we have fires that kind of come back to life because they smolder underground over the winter, and then they can be re-sparked into the spring. And so you don't have a fire season anymore because they're kind of burning one way or the other. Just kind of freaky. And then, like I said, this can lead to feedbacks of carbon emissions. This is a cumulative carbon emissions from fires. So this is quite alarming, and people have been really thinking like, oh my gosh, what does this mean? The world's on fire. I do want to level set just a little bit. This is a lot of carbon, but it pales in comparison to fossil fuel emissions, right? We're talking like several percent relative to what we're talking about in annual fossil fuel emissions. So yeah, if we stopped all fires, we're not going to solve climate change. Let's be very, very clear. And most of the time in most systems, the carbon is recovered. What we worry about in peatland systems, of course, is that it'll take millennia for this to get recovered. It's also true that at least until the most recent, like this year, we saw a little bit of an uptick, but actually on the global scale, we're actually seeing a decline in area burned, which is sort of fascinating until you start to think about why. And you know, a lot of the burning that we've had across the world has been caused by humans, biomass burning, like I studied in my master's, people burning for agricultural reasons, land clearing. Guess what? We're mostly an urban society now. So we're burning fossil fuels. We're not actually burning our landscapes on average. Now, that's not true in places like the Amazon and in Congo Basin, many other places, the peatland systems of Indonesia. We are burning for these reasons in many places. I don't mean to say we're not, but I am saying that we are a little more, there's more geographic hotspots of where this is happening. And the Western United States and Canada is one of those hotspots. And so that's why we're seeing this big uptick. And we've been able to associate that with a changing climate. So we now can look at the correlations between the fire size, the fire occurrence, the fire extent, its pace, its severity, its impacts, and we can look at it being associated with hot and dry environments. So it's getting hotter, it's getting drier. These are the conditions for fuels. So what? Well, now it's burning structures. It's burning into the built environment. And this is causing a lot of concern, obviously, for us. This is the fires in San Francisco, the sort of Red Mars event. You may not recognize this one, but this is the fire. It was a New Year's Day, I think, in Colorado. So this was a brush fire that came into the outskirts of a pretty, you can see, pretty nice neighborhood here. I don't like this fire, but this fire tells us an interesting story because not only were these homes destroyed right on the edge of this, But we also had the homes that weren't destroyed also being unlivable because the smoke carried all of the chemicals from the other homes into the homes across the street. And so think of what's burning now when we're burning through lived environments. We're not just burning wood anymore, which is bad enough. And the science around smoke emissions is really evolving quite rapidly to show the negative consequences of just wood smoke. But we also now are burning diesel. We're burning our rugs. We're burning our washing machines. We're burning our cars. We're burning all the paint on the walls. All of that chemistry is going up into the smoke. So the health concerns about this are actually quite alarming. And we're just now starting to really get into the science of this. And so, and that's aside from the obvious detrimental effects, disastrous effects on people who actually are experiencing these wildfires. This is the fire in LA not too long ago. So it's pretty clear, and it has been written that we are living in something called the pyrocene. I think this is interesting from my geological perspective. I'm curious what you guys think about this. But this idea that we have evolved our livelihoods to use different sources of energy through time, whether that's sunlight, oxygen, and so on. And now we're sort of been dependent on fire. At least this article suggests that now combustion is a big life force. And if we think that way, we think about our fossil fuels, we think about the biomass that we depend on for our day-to-day life, that is really shaping our society. So this Prometheus myth here is apt. We have this ability to control fire now. We know how to put fire on landscapes. We have done that for millennia, but we also have these the combustion process has meant that we have feedbacks now that we've created a fire force that we actually can't control all the time. And so this is kind of a tension and a lesson, was Zeus right that we shouldn't have had this power of fire? Okay, so with that as context, I'm going to talk about Western firescapes really quickly. A lot of science here. I'm going to keep this very high level. I'm not going to give you all the data. I'm just going to give you the story. But if you have questions, let me know. Smokey Bear, one of the most successful advertising campaigns we've ever had in the United States. You all recognize, hopefully, especially if you're from the United States, you recognize Smokey Bear. If you've been to a national park in the United States, you still see signs of Smokey Bear out. Interestingly, Smokey Bear came of age in the 40s and 50s in a post-World War II environment about a sort of more isolationist, protecting our natural resources mode of how we were managing our forests. And it was things about, we don't want fire in our system. We need to remove fire because it's burning up our forests, and we need our forests for national security and all sorts of things. And fires are a waste. And so the slogan was, only you can prevent forest fires. Anybody know what the slogan is now? Only you can prevent wildfires. Because there's a lot of fire science that's happened over the last 80 or so years where we've realized, well, actually some fire is good and some systems depend on it. It's the bad ones that we don't want. And so there's kind of a shift in tone, but this is now dated, but this is my daughter. She's now at grad school at BU. So this is a long time ago. But we happened to run into Smokey Bear in central PA, which isn't really doing a lot of burning at the time. And so it was kind of interesting to see how pervasive Smokey still is today. Okay, so that tale of how the Forest Service has adapted to fire is really the tale of many forests across the US. So these would be a very typical forest stand in the southwestern United States, sort of in Arizona, New Mexico area, where you have these ponderosa pine ecosystems. And with frequent fire, it would return, every several years or so. The understory is not allowed to regrow very extensively. But if you take fire out of a system for 50 to 80 years, you're going to be missing 5 to 8 fires over that time period. And over that period of time, maybe more, things start to grow back and you start to get these very dense forested systems. In this scenario here, you would have the fires licking the bark at the base of the tree, but it would never get to the canopy. But in this scenario here, you have the fires actually being able to climb up into the canopy and actually kill the trees. And that we call them ladder fuels because they can climb up into the canopy. And so a lot of the focus has been to remove these fuels, the sort of little stuff, so that we can support the maintenance of the ponderosa pine ecosystems, and to put fire back in the landscape in a managed way pretty frequently, but at low intensity. But we have other systems, like ones I studied in Yellowstone, that actually are not adapted to that kind of fire system. They're actually adapted to a different kind of fire system. And we call these stand replacing fire regimes, where they actually burn and they kill all the trees pretty regularly for like the last 10,000 years. We know this from all sorts of historical paleo records, from charcoals, from sediment, from pollen, that pretty much for the past 10,000 years, it has burned on a fire cycle of every 100 to 300 years. And that's a pretty long time. It allows a forest to establish and to regrow, and then it burns again, and then the cycle repeats over that time period. And so putting in a small fire, low intensity fire doesn't actually do much for the system. It's kind of a blip, and why invest in that when the system is not adapted to it? The 1988 fires in Yellowstone, they're often, when I was studying them in the early 2000s, we were looking back at the 88 fires and thinking, well, that was a really unusual fire because it burned Yellowstone. Yellowstone was the world's first national park. The national park model was exported after the success of Yellowstone, briefly said. So we've been studying this fire for a really long time. And this is a helicopter image looking over the landscape right after that burn. It burned 40% of the park, which is a lot of the park. All of these polygons are the burned area, and the orange in the middle are all of the previous 100 years. So by comparison, this was a big fire year for Yellowstone. But again, if you look at the paleo record, it's actually consistent with what we would expect. It had been about time, if you will, for a fire to occur. The fire also created pattern on the landscape. It had areas that completely burned, obviously, those black areas, places that were unburned, the green areas, places where it burned at low severity and the needles were still on the trees. Those are those sort of golden areas. It basically reset the template for the ecosystem, reset the age class structure, reset the species composition, and so on. But importantly, what we and colleagues of mine have shown is that it naturally reseeded after the fire. And so if you go to Yellowstone today, I always have to ask this for people in the East. How many of you have been to Yellowstone? See, it's depressing. You guys need to go to Yellowstone, go out west, go to these parks. They're amazing places. But if you go, you will see signs like this, and you'll be, that professor said something about these signs. Okay, these were put up by the Park Service because they need to educate the visitors to say, we didn't plant all of these trees. They came back naturally. It was part of an education to say the system has the ability to recover if you give it enough time. And so colleagues of mine have studied this. Sorry, I think I skipped a slide. Yeah. And the major reason why those systems recover is a trait that the trees have adapted to over this 10,000 year period of having serotinous cones. And this means that the cones are closed until they get heated to a certain temperature, and then they literally pop and release, and they will allow the seeds to fall and to recover on the ground. Now that trait of serotiny has geography. It has a pattern on the landscape, and it looks to be like that the most serotinous cones are lower elevation, where you're more likely to burn at that shorter interval, like 100 to 150 years. And the open cones, I'm going to anthropomorphize for a second. Tree's going to say, I'm more likely to die by natural causes than I am by fire within 300 years. So I'm going to sometimes invest in serotinous cones, but I'm also going to invest in non-serotinous cones because I want a few seeds to be released every once in a while. And so there is this evolutionary pattern kind of locked into the landscape that created patterns in post-fire density after some of these bigger fires. And we've mapped that out. And again, sort of hard to see, but thickets of vegetation that you can't even walk through, tens of thousands of stems per hectare, to places that are actually quite open and quite bare if a wildfire were to come through, because they just didn't have that serotinous cone trait in advance of the fire. And you can see orders of magnitudes in terms of tree density variability across the landscape. So we've been studying that, and I think this is my only data slide that I'm going to show you today, but basically this is the percent of total ecosystem nitrogen in the ecosystem. You can think of that as carbon, you can think of it as biomass. The patterns are absolutely the same. Percent live, percent dead, and percent soil. So we have, here we'll have the percent live regrowth. So it starts out very low and then it kind of tapers off. And up here we have the amount of sorry, I can't even read my own slide, soil, and then this is the dead wood as well. The point is, at the beginning of post-fire, at the stand age, very young, there's a ton of variability across all of these stands because of post-fire or pre-fire stand density. Fire comes through, very different patterns, this reshuffling of the landscape. But what we also found was that, well, during these different stands, you have these different kinds of patterns. But then work that we've shown is that by the time you get to be about 150 years old, basically the lines are flat statistically. And again, I have more to show to back this up, but that is basically the time the fire regime has been set, as we know from the geological record. And so it would suggest that these systems are resilient to even the most stand replacing wildfire. Now, this is a really hard sell to most people. When they see a wildfire, they're like, oh my gosh, it's a disaster. The world's first national park is burning up. But if you listen to the ecosystem and you study it over long periods of time, you start to understand that it actually has capacity for resilience. And so, for example, we would see, these are stands that I actually studied where you have a 2 years following the fire, really hot burn. And you can go back to that literally the same location. I should have pointed out in the previous one. Oh, no, you can't see really, but there's a mountain right behind here. There's that mountain in the back. Basically the same location, systems starting to come up, the trees have fallen down. If you were to look closely, you see a lot of pines, seedlings and saplings starting to come back into the ecosystem. You have lupin plants, excuse me, that are putting nitrogen back into the system. The system's essentially recovering. You come back about 15 to 17 years later, and this is what it looks like. Mountain is back there, I promise. But now the trees have, self-thinned, and the big ones are winning, and it's starting to grow back. You give it enough time, 250 to 300 years. This is essentially what it would look like. This is an old growth system in the park. So, what we've learned really is that fire has geography, and we call that the field of pyrogeography. That's at a global scale, and it's also at the scale of a Yellowstone park, where you have to look at that fire pattern as a product of geography. That stand replacing fires reshuffle the deck, kind of, but the deck is the same if you give it enough, if your scale is right. And with enough space and time, the system comes back. So this is, a story of resilience that I developed in the early part of my career. Or is it the multi-billion-dollar question right now? Because we actually spend billions and billions of dollars in fire suppression. And when we started to look at our data again with this new lens of like all the big fires that are happening in the 2000s, we started to see these interesting correlations start to creep in. Like actually some of the more recent fires in the West were happening when we had years of less snowmelt and hotter and drier summers. And we started to be more aware of climate change effects and showed strong correlations between climate change and wildfire in the West. Okay, well, then we did modeling. I lied, sorry, a little bit more data. But the dotted line at the bottom here, this is the amount of area burned in the greater Yellowstone ecosystem in 1988. And then we did some model projections of how much might burn into the future. So starting about here, moving into the future, and our model projections show that you would start to burn all of Yellowstone quite frequently all the time. And we said, if you give it the same conditions that occurred in 1988, which was 5% relative humidity, 40-mile-per-hour winds, if you give the system that kind of climate, as the climate model suggests will come, you will burn more. And so we're like, oh, well, that would be a different scenario. What would that look like for Yellowstone? And here what we're seeing is fire rotation mapped by color, with the blue being sort of this more traditional geological time frame of the dark blue being 150 years. So in the historical period, we'd expect to see all blue. Oh gosh, sorry. But what we're seeing is by mid-century, we don't even look at the black one. Look at the mid-century 2035, which is not that far away. 2064, we start to see fire rotation in the reds, which is an order of magnitude more frequent than we had before. So 150 to 300 years, we were projecting in our models, you would see 15 to 30-year fire rotations. So then the question is, will Yellowstone's vegetation recover in 15 to 30 years, even with a trait of Serotiny? Was it actually that resilient? And so you have these systems of stands, ones that I studied in my career, recovering. This is a 17-year-old stand Right across the road, that same 17-year-old stand burned in a very, very hot fire just recently. So even in my own life history, we started to see that systems can change pretty radically, and systems that were supposed to be 150 years were burning in 15 years. Will it be resilient? This is a system coming back. Again, a little hard to see, but it is starting to come back. We're starting to think about, how to help the systems come back, how to promote resilience. This is me and my son a few years ago walking through the landscape there. It is starting to recover. But how many times will the system have to be hit before it's not recovering again? That's the question. And work by my colleagues, my students, trying to think about a concept like spatial resilience. Are there places on the landscape where, especially in the surrounding Forest Service lands, would you promote stocking of certain trees because they're more likely to survive? And how do you inform management to help promote spatial resilience into the future? Because we know the system can have resilience, but we just don't know how much it can take into the future. Okay, all of that leading into this last section. I know I'm keeping my eye on the time here. I want to leave lots of time for discussion, but I want to introduce this idea now into the East. Okay, so with all that as backdrop of like, wow, this fire has a geography, systems are resilient, but what about my provocative title, will the worst wildfire happen in the East? And, if you think about it, the novel firescapes that we've seen across the world, like in tundra ecosystems and in Australia, in the West, why wouldn't it happen here, right? On the one hand, that's sort of like, well, what kind of hubris would we suggest to think that it wouldn't happen here? That's one way to look at it. The other is to say it's going to happen, but it's going to be different from how it's happening in other places, in which case, what do we know or what don't we know about what those risks are? And so that prompted us to think about this more holistically. And there's been a lot of work and actually a lot of controversy about how much fire should be here. We don't know is the full answer. Because a lot of the evidence of this has been erased from the surface of the landscape as we clear-cut it, as we remove Native American populations. We don't have a lot of history. What we have been able to piece together is that fires did burn in some areas through human lit fires, and we know that there was extensive burning associated with the clearing of forests for iron ore burning, deforestation, agricultural expansion. But the picture is actually quite complex. Again, I don't have time to go through all of the drivers and the variables, but we can think about the ones in red as the risk factors: hazard, exposure, and vulnerability. And there's lots of different factors that play into this. And we have to go back in time, but we also have to go into the future to think about how frequent will some of those situations be into the future. And then we think about, well, what is unique to the Eastern United States compared to some of these other places? And it's maps like this that kind of keep me up at night. This is the wildland urban interface. So this is where the built environment is intermingled with fire-prone landscapes. And if you can tell, the East is on fire, not literally, but all of the orange and red area is in the East. And we think about the West a lot, and we should, because there are communities in the West that have been devastated by fires. But in the East, we actually have more people living in this environment. We haven't worried as much because we haven't had as much fire. So there's a concern there, though, like what would happen if that shifted? The Southeast, of course, has had a lot more fire and a more history with fire, and they do a lot more proactive prescribed fire burning, but that has not historically been the case until recently in the Northeast and the Mid-Atlantic region. The second thing that's different about the East than the West is that we have a lot of different ownership in the East. So in the Eastern United States, most of our forests are actually privately owned. So that could be major forestry corporations, or it could be private smallholder landowners. They're not largely federally managed, which is different than in the West. And so you have Western systems where you have fire risks that's being managed by the Park Service, the Forest Service, and so on. In the East, you have this intermingling of lots of different ownership classes that are very state level driven as well. So you have a lot of state lands, you have a lot of different agencies, and they all have their different governance systems and different policies and different histories of fire. So the coordination of emergency fire response or proactive fire management to manage sustainable forestry is a lot more complex out here, which means we haven't coordinated that well. And I kind of became aware of this when in 2009 in Pennsylvania, a prescribed fire burning act was passed, which reduced liability for burn bosses to go out and actually put the forest on fire purposely. And that was a big relief for the managers because it meant they could go put prescribed burns on the landscape and do what they wanted to do, which was manage for habitat. At the time, they were managing for things like oak and pine forested systems, which is where a lot of game species depend. So our oak systems, pine systems, hickory, they support our quail and our turkey and so on, and our deer. And so the Game Commission for the state of Pennsylvania has wanted to put fire in the landscape to manage habitat, not fuel risk, but habitat. But now we're putting fire in the landscape in a place where fire isn't common. What do people think about it? What do the communities think about it? So we worked with fire managers, we held focus groups, we started to do survey work to think about those risks and benefits, sort of opportunities and barriers to putting fire on the landscape. And a lot here, but I just focus on two things here, the top bar and the lower bar, and the fact that there is this multiple levels of opportunities and barriers. So one of the top opportunities that managers told us they were interested in was at the landscape level, institutional coordination. That if they could just work with other agencies who were trying to burn and they could manage at the landscape scale, things could get done a lot more quickly. At the other end, managers, this individual level component came out, which I thought was just super interesting, fear or stress. That fire managers had this innate and individual level concern about putting fire in communities where people were living, and they didn't know what people thought about it. There's concerns about liability still. And so they're living with this thing of knowing they need to do it, and they need to do it well, but being handicapped by all of these sort of social factors, in addition to biophysical factors that we can talk about. So anyway, very complex story. And we also then interviewed people who were using the landscape. And again, a lot of data here, but interestingly to us, 75% of the people that we talked to actually supported burning. Yet managers are feeling a lot of pressure and concern. So there's a sort of trade-off or imbalance between what communities were thinking and what managers were thinking. But I should caveat this, that we only did this in one location. We need to expand this kind of work to really see how broad this is. For example, we did work in New Jersey and in Pennsylvania, and we found that ticks were a really good unifying theme. So if you told people that fires reduce ticks, people are like, great, that's awesome, bring it on. And the interesting part of that is we don't actually know how long that would be true for, because if you get your deer coming back in, you're getting your mice coming back in, you might have a short-term effect where ticks get reduced. We've seen that, but you also might have a long-term or mid-term increase. Anyway, that's another story. But how do you message that? How do you communicate between managers? What the goal might be different. The goal might be habitat management, but maybe ticks are the vehicle to get community buy-in. Okay, but closing up now a little bit to think about wildfire. Like in all of that work, we were not thinking about wildfire risk. But we know that in the East, there have been large wildfires. This is the Gatlinburg wildfire, Southern Appalachian region, $2 billion of losses, people killed, a lot of infrastructure damaged. It can happen. We know that the East is not immune to wildfires as of a couple years ago. And if you remember, we had huge smoke events here in the East. I was getting calls from the press all the time, like, what's going on? Like, why are we getting all this smoke? So we know we're not immune to fires happening elsewhere from Canada or the Western United States, but we still, it doesn't happen here until it does. 2 years ago, we had a pretty big fire event across the Mid-Atlantic in the Northeast. This is a fire in central Pennsylvania, which again, I study wildfires in Yellowstone. I don't study them in Pennsylvania. Well, guess what? Now I have a new study site. So we're studying wildfires in Pennsylvania. So that gets you thinking, like, wait a minute, I've seen this record play before, I've seen this happen. What do we need to pay attention to? So we started to think, what are the research gaps in studying Eastern wildfire science? And I've listed those there, most of the things that I've already discussed, so I won't belabor them. except for one of them, which is around flashy droughts. Like what we saw in the 2024-2025 season for the East is that we had a sort of extended drought in the fall, and that is the spring and the fall are our fire seasons in the East. And so the problem is our climate models don't do a good job of these short-term drying events, nor do we do a good job of predicting like how the fuels will respond to that short-term drying events. So there's some climatological questions there. And so we don't know if the risk factors developed in the West or nationally are applicable to the East, nor whether they are informed by the East's unique social, physical, environmental factors that drive fire hazard, fire behavior, and community exposure and vulnerability. At the same time we're developing this idea, we're having papers come out that are actually showing robust projections of future fire probability for the Eastern United States. Fire regimes of the Southern Appalachians may radically shift under climate change, increasing large wildfire risk in the United States. So we're starting to see this buildup of evidence pointing to the modeling work that's saying, hey, things are changing here, we should pay attention. And we're starting to get some large wildfires occur. So this is, again, across the Eastern United States. We have ones in Louisiana, Minnesota, Massachusetts, South Carolina, fairly large fires where we can map severity patterns. We can start to map and understand, which means we can also map recovery, and we can start to understand how these systems are going to recover from these. In fact, in our project, what we're hoping to use is these case studies to be able to unpack some of the drivers that cause these fires and how we might learn from them. We also have data sets of where fires have occurred, and they're horrible for understanding this. And so one of the goals we have is to try to improve data sets so we can better understand this. I'm hoping that you're looking at Massachusetts right now, because that's one of the fascinating things for me being here on my sabbatical studying Eastern wildfire. I'm like, what the heck's going on with Massachusetts? It's on fire. These are all of the fire incidences that are reported by the state agencies. So what this tells me is that Massachusetts has a great reporting structure. And it's true, I know the fire manager there, he's great. But maybe not so much in the other states. Like clearly there is a state boundary issue here with data reporting that's not a biophysical or ecological pattern. So how do we coordinate like that? And, what are we missing? What data gaps are there? And then, because some of this work has happened in New Jersey, a colleague of mine said, have you heard about that Rolling Stone article, which is the nature of my talk title here? Will America's worst wildfire disaster happen in New Jersey? New Jersey is a fire-adapted ecosystem. The pine barrens there have been managed proactively with managed fire prescribed burning for a long time, over 100 years, because those systems do burn quite frequently. And managers have said that fire can spread across the state in a matter of days. And it's going to be in the Cherry Hill neighborhood outside of Philadelphia if they're not careful. So the state has a state-level wildfire protection agency to manage that risk, and they do a damn good job of it. But most other states don't, right? And so, okay, great, they don't have pitch pine ecosystems, maybe they're not as at risk, but we know anything can burn under the right conditions. So how can we get ahead of that issue? And this is for Pennsylvania, but this is the number of days over the projected days, annual temperatures above 90 degrees Fahrenheit, which is really hot for Pennsylvania. And you can see in the midterm and long term, most of the state is going to get hotter, and that's going to mean the vegetation is going to dry out. And we have this trend as well in our most recent climate assessment, where you have the number of consecutive dry days in the fall basically increasing over time. And so if you have hot conditions, you have more extensive dry days. Even if annually it's getting wetter, we could have situations where we have higher fire risk. I should say too, we don't even worry about ignitions, because ignitions are happening all the time because humans are in these landscapes and humans cause most of the fires to occur, but the fuel has to be the right dryness. So the ingredients are all there for fire to occur, and through observational data, we've also found that the fire season is kind of shifting in different ecoregions based on some of these changing climates, but the mechanisms for that are unclear. So we're working with Columbia and their climate models to try to understand some of these dynamics. Our approach is to think of this as a firescape where we're mixing social and ecological factors, because you can't understand Eastern wildfire by just looking at the fire itself. It's happening in the context of all of these other situations, and many of them are social. So we have a large team that we pulled together to do this work across different research stations across the East. We have some core questions that we're going to be asking to focus our work. What are the wildfire risks? And then what are the community vulnerabilities to future wildfire? But really thinking about the research agenda that would try to answer those. And because I'm really committed to how we're training students to think of this, it's for graduate students, but we have a graduate summer training program where we're trying to pull together. It's open now if you know of others who are interested, where we're pulling teams of students together to try to address some of these challenges in collaboration with our team and our local partners. We also are starting to initiate some empirical work. We're taking my students out into some of these fires that have burned in Pennsylvania, starting to ask questions about the fuels, about the fire effects, what's happening in the soils. See, now I'm coming back to soils. I knew something after all. And thinking about biogeochemistry, and we're even using things like terrestrial LiDAR scanning to look at post-fire stand structure, to think if we can see how fires modify post-fire structure and get at resilience in the Eastern United States. And like I said, we're thinking about identifying some of the study sites around here, like around Massachusetts, where we might be able to do some of that work. Finally, that's my son, now older, my youngest, in my hometown backyard in Amherst, Massachusetts, where I cored finally. I wish I had done this 30 years ago, but I finally, not cored, we are going to do some coring, but tagged all of these trees in my backyard. Because I think they've changed a lot in the 30 years that I grew up there, or since I've left. And we're going to go do a little home backyard study as well, because I think these forests are changing, and they always have changed. And how will they change into the future? Hopefully, they won't burn. That's kind of what I'm really hoping, because we live in the woods. So thank you for your attention. I know that covered a lot of territory, but I'm happy to answer any questions that you may have if we have time. I know it's 1 o'clock. Thank you so much.
Thank you so much for sharing so much wonderful information. We have time maybe for 1 or 2 questions.
Thank you for this. I wondered if you could talk a little bit about the changing funding landscape and how the Forest Service is kind of responding under, changing political regimes.
Yeah, probably a 2-part answer there. The funding, this is actually coming from a National Science Foundation investment, which is cross-directorate, and it survived any of the sort of spotlighting on research over the past year. And so it's actually a robust program. It's thriving. We were actually funded through a partnership with the Gordon and Betty Moore Foundation and the National Science Foundation, and the Gordon and Betty Moore Foundation selected ours for funding, which is great. But I do think we're going to see more of that partnership occur between sort of outside non-federal partners who are interested in this, because I've seen a lot of philanthropy interest in fire in particular. So that's one part. The Forest Service itself is, a more interesting and nuanced discussion in terms of the relative balance of investing in wildfire risk management and proactive strategies to support prescribed fire burning and other kinds of forest management strategies. One size does not fit all, and that's been something as scientists we've tried to share back with the Forest Service, that if Smokey has taught us anything, it's that fire suppression doesn't work, yes, but also not every system is adapted to the same kind of fire regimes, and each system needs to be locally managed. And so what we're trying to do as scientists is make sure that at the federal level that message gets conveyed. It's still going back and forth a little bit, but that's where we are on that issue. It's a good question.
We'll do a final very quick question and quick answer. And I invite everybody to talk to our speaker after the talk.
I'll make it really fast. I was curious about, I know you were talking about sort of the way that there was this study about how folks in New Jersey in the community, what their sort of understanding and tolerance was of wildfire management, as opposed to folks in this work and what their perceptions of the community's perceptions were of this work, what those sort of differences in perceptions of tolerance. Yeah. And I'm curious, in your opinion and in your work and in your connections to like socio-ecological systems and community resilience, across the East Coast and beyond, because New Jersey is sort of an exceptional state in terms of its sort of ecological work.
Fire history, yeah.
How do we continue to sort of bridge wildfire tolerance,
Yeah.
or I guess wildfire management tolerance?
Right. Great. It is a great question. And I would, based on my understanding, the social science work has not been done here in the East. There is a lot of social science work. Almost all of it is in the Western fire context. And so we don't know a lot about the East. If our study, which was comparing a place like Pennsylvania where fire was new to a place like Pennsylvania where fire is more established, if we can learn anything from that, and also we include Maryland, I should say, it's that there is geography to that, and that but even in even in New Jersey, where they are used to prescribed fire management, they're used to wildfire risks, you are also seeing a situation where you have a lot of community turnover, you're having a lot of tourism, you have people moving from New Jersey and retiring down in New Jersey, but having grown up in the forested landscape. So even there, they're challenged with that messaging of how do we communicate this. And so I think this is also going to be a very localized issue for communities, no matter where you are. And we do have goals to kind of, just briefly, because I know we're out of time, but to extend that and to more broadly try to understand those nuances, because we don't actually know. But I do think there is a growing awareness socially. Like now people are actually thinking, the smoke events, I think, of the last couple of years really woke people up to thinking about fire. And the messaging from the West is certainly getting received here. The question is, what story are we telling managers about how to manage for that? Because again, I don't think it's going to be the same as in the West for all the reasons I described, but what should we be telling them? And we're really at the cutting edge of that research, I think. Hope that helps.
Thank you.
Thank you. Let's thank our speaker one more time,
Thank
please.
you.